Okay, hello people. This is the solution to homework number 21. Okay, so homework 21. So let's do number 15. They write this complex number 1 plus I, and they ask you to sketch it in the complex plane. First of all, if we put some markers here, like there, this is the real axis. This is the imaginary axis. So if you look at the real part of this is 1, and the imaginary part is also 1. So there is the complex number z, okay? And then it says, also sketch 2z. Well, 2z is equal to 2 plus 2i, right? So its real part is 2, its imaginary part is 2, 2 real, 2 for imaginary, and there is the complex number 2z. It says, plot minus z. Well, what is minus z? Z is minus 1 minus I. If this is z, minus z is minus 1 minus I. So you go negative to the left, negative down below, and there is your minus z. And finally, it says plot 1/2 of z. Now, 1/2 of z, if this is your z, is going to be 1/2 plus 1/2 I. So you go a half to the right, a half above, and there we are. So this one, this is 1/2, and this is 1/2, is 1/2 z. Okay, let's do the other one. Same type of animal, except that this is number 16, and the z is given as -1 plus I root 3. Okay, so let's get z first. This is the real, this is the imaginary. You put some tick marks here indicating 1, 2, 3, etc. So notice that the real part is -1, so you go to the left by -1, and the imaginary part is root 3. Root 3 is approximately 1.7, so it's going to be right there. There's your z, and this is approximately root 3, 1.7, and this is of course -1. And then it says plot, okay, what's the other one? Plot 2z. Well, if this is z, 2z is going to be -2 root 3. So the real part is -2, so I go to -2, there's -2, and the imaginary part is, oh, sorry, this is a plus. Okay, yeah, you multiply it by 2, so -2 plus this, there's an I here, and this is approximately 3.4, so you go -2 there, 3.4 up. So if this is a 4, and this is a 2, and there is your 3, 3.4 is roughly here. So there is your 2z, okay? And then it says plot minus z. What is minus z? If z is given up here, minus z is 1 minus I root 3. So let's see, let me use a different color here. Okay, so 1 is right there. There is tick mark 1, and minus root 3 is roughly -1.7, so this is a minus 1 down. Minus 1.7 is somewhere here, and it's there. There we are. This is minus z. Okay, and this number is root 3 minus root 3, right? And finally, it says 1/2, plot 1/2 of z, and this is going to be -1/2 plus root 3 over 2i. So let's see, use a different color here. All right, so -1/2, so there's your -1/2, roughly there. And root 3 over 2 is about 0.8, because I said root 3 is almost 1.7, half of it is 0.85, so it's going to be right there. So this is 1/2 of z. Okay, so let's go to problem 19. Let me clean this up. Okay, let's go problem number 19. What is it asking? It says, okay, Z1 is 2 minus I, Z2 is 2 plus I, do a bunch of things. So, okay, let's, first of all, let's find Z1 plus Z2, that's easy. Z1 plus Z2, you just add these up, you're going to get 4, 2 plus 2, look, 2 minus I plus 2 plus I. So this is going to be 4, okay? What else do we want? Z1 times Z2. Z1 times Z2, let's work it out. So it's going to be 2 minus I times 2 plus I. And this is going to be 4 minus I squared. I'll let you, what do you call, FOIL it. And this is going to be 4 minus 1. And this is 5, okay? So it says plot Z1, Z2, and Z1 plus Z2 and Z1 times Z2. Let me use a different color here, right there. Okay, Z1. Let's put some markers. Some markers there. Okay, Z1. Real part is 2, imaginary part is -1. So there is your Z1. Z2. Real part is 2, imaginary part is +1. So it's up there. So there's your Z2. Z1 plus Z2 is 4. Z1 plus Z2 is 4. So it's right there. Z1 plus Z2 is actually a real number. And Z1 times Z2, you work it out as 5. It's right there. It's right there. This is a 5. Z1, Z2. As simple as that. Okay? All right. Let's go to number 21. Number 21. It says, sketch this set in the complex plane A plus BI, where A is negative, real part is negative, and B is positive. So if you look at the complex plane, this is the real part, this is the imaginary part. I want all complex numbers that have a negative real part. Now, remember, real part is this axis. So anything to the left of this, point, for real part is going to be negative. And anything above the above that point is going to be positive. So when you look at it, the region that you want is right here, shaded. Any point in this portion of the complex plane has a negative real part and a positive imaginary part. And by the way, it also applies to the point. If you look at it, if you check it, it also applies to these edges. Okay? If in the event that I didn't have these equal signs here, then you exclude the vertical line and exclude the horizontal line. It's only the stuff that is shaded, excluding the vertical and horizontal line. But that is not the case. Our problem was what I just gave you. Okay, so let's do the next one. Next one is this is number 22. All complex numbers z equal to a plus bi, such that a is bigger than 1 and b is bigger than 1. So once again, the complex plane looks like that. This is the real part, this is the imaginary part. Anything with the real part bigger than 1, if this is a 1, is to the right of that line. And anything with the imaginary part bigger than 1 is anything above that line. So if you want this to be true and that to be true, we want to be here, excluding these dashed line because there is no equal here. It cannot be equal to 1 either way. So that is the region in the complex plane. Okay, let's do the other one. Number 23. Go down here. Number 23. The set of all z such that the modulus of z is equal to 3. Now remember, modulus of z is the distance from z to the origin. So if you take a point here, this distance, we're saying it's equal to 3. So if you look at all the points with distance being 3, basically you have a circle of radius 3. This circle of radius 3 represents that set. Okay, let's do number 4. 24, that's what I meant. Number 24, it says the set z such that modulus of z is bigger or equal to 1. So that means the distance to the origin must be bigger or equal to 1. Now remember, modulus means distance, okay? So here, if this is the marker 1, so we're talking about a circle of radius 1. If this was equal to 1, not bigger or equal to 1, it would be that circle. But because it says the distance is bigger or equal to 1, that means you want all the stuff that is in the shaded region, and that includes the circle itself. Okay. 25, same kind of animal. 25, set of all z's such that modulus of z is less than 2. Now remember, here there is no equal sign, so you draw the circle of radius 2. It's the circle of radius 2, and you take only the points inside of that circle. Exclude the circle itself. The circle itself. Anything inside of it is perfectly okay. Itself. Okay. Let's do number 26. Number 26, same kind of animal. Number 26, a set of all z's or z's such that modulus of z is less than or equal to 5. If I had this, it would be inside the circle of radius 5. Bigger or equal to 2. If I had this piece, it would be a circle outside the circle of radius 2. So here's the situation. You draw a circle of radius 2. You draw a circle of radius 5. You want it to be inside of the circle of radius 5 and outside of the circle of radius 2. So including the boundaries themselves, those circular boundaries themselves. So it will be this region, and that includes this circle and includes that circle because the equal sign that you see up there. Okay, let's do number 30. Number 30, what do we have here? It says, here's the complex number, z equal to 1 plus root 3i. It says, write the complex number in polar form with argument theta between 2 pi and 0. Remember, I told you that argument is not unique. You know, anything that you get for argument, remember, theta is tan inverse of b over a. Anything that you get here, you add 2 pi to it, still argument. However, here it says, just give me the first one, the smallest angle theta, the smallest argument. Okay, so well, we don't really have to draw these things, but it's helpful. So there is one, there is root 3, the complex number is right there, okay? And the modulus is, or r, is equal to square root of 1 squared plus root 3 squared, which means square root of 4, which is 2. Incidentally, what we just did is to find this hypotenuse. That's what we did. Okay? Now, as far as theta goes, theta is equal to tan inverse of, you look at your b is root 3, and you look at your a, it is 1, and if you go back to your calculator or remember what this thing was, it was pi over 3. So this is the angle pi over 3 or 60 degrees. Okay? Let's do another one. This is number 31. Your complex number is equal to root 2 minus root 2i. Okay? First of all, let me locate that for you. Root 2 is the real part on this side. Minus root 2 is the imaginary part, which is this side. So this is root 2. This is minus root 2. And there's my complex number. Okay? Now notice that that distance is the modulus. So modulus of z, which we also call it r, equal to square root of root 2 squared plus minus root 2 squared. So this is square root of 2 plus 2, which is root of 4, which is 2. So there is 2. So modulus is 2. And the angle, just look at this diagram. I don't have to use tan inverse. You can see that that is the theta that I want. Theta is equal to let me see now. If you look at this, it's going to be 2 pi minus pi over 4. Just look at this. It's 2 pi minus pi over 4, and that is equal to 7 pi over 4. I just want to caution you, if you blindly go with this tan inverse of minus root 2 over root 2, what you will get from the calculator is minus pi over 4, which is going to give you that piece. And there's nothing wrong with that, except that the problem asks us to write it with theta between 0 and 2 pi. By the way, the one thing I forgot to write, the polar form means that this is equal to 2 cosine of 7 pi over 4. I'm going to cross this out, okay? Plus sine of 7 pi over 4, and this is multiplied by I. So let me write the I. Where is it? Let me write the I right there. I times that. Now, in the top one, I should have also written for you what the complex number polar form is. So z is equal to r, which is also 2, happens to be 2, times cosine of pi over 3 plus I sine of pi over 3. Sorry, I ran out of space here. 2 times cosine of pi over 3 plus I sine of pi over 3. I have 2 more problems to do here, so I'm going to stop this thing and do that in the second video segment.